Okay, so I'm going to try and go through this as much as I can in one go, but I might have to break this video up. So for the first part, so question 1, write the equation in the factored form of the cubic function f of x with zeros at -5, 3, and 6. So a couple things that can be mentioned. We're writing the equation in factored form. So this is a form that looks like this, where you have like your function f of x is going to be like x minus 1, x plus 1, or something like this. These are all like your factors, as opposed to something that would be like in standard form, which would be something like all of this expanded. So we could do something like this minus 11 or something. So that's just a quick reminder of what factored form is, and specifically they ask for factored form with 3 zeros. So the zeros are given as -5, 3, and 6. So in other words, -5, 3, and 6 have to be the numbers that make this whole function equal to 0. So we're going to adjust that. So we have that there. So again, so it's -5, 3, and 6 are with zeros. So I'm basically asking myself if x is equal to -5, this whole thing should become 0. So for this first term, for this first factor rather, if we let x equal -5 here, I'll have -5 plus 5, and this will be 0. So this first factor will be 0 times something and something, -5 and -5, and like it doesn't matter whatever is in these other two factors because this first one is 0, and 0 times anything will always be 0. So that's what we're looking for our to figure out what we have to put here beside these x's. So we're just going to basically filling in the blanks, like what these x's need to be. So this first one has to be +5 because -5 plus 5 will give you 0. And that same reasoning, if we have a +3 for our second 0, I'm going to write -3. Because if we, again, substitute in x as +3, I'll have 3 minus 3 for this factor, which will again give me 0. And then I'll have something times 0 times something. And it doesn't matter what those somethings are because I'm multiplying it times 0. So it's all going to become 0. And then for the last one, we have 6. And so I'm going to have x minus 6 because when I again have 6 minus 6, this last factor becomes 0. So this would be our answer here. So there's not enough space to write it really in this spot here, but like that would be our answer for number 1. Question 2 asks the maximum number of x-intercepts that this function can have. And this may look rather complicated, but it's not that bad. So what we're doing here basically is we're looking at the highest degree of this polynomial, which is a 4 here. So very quickly or very simply, the answer to questions like these is basically to take a look at the highest degree, and that's basically going to give you your answer. So the highest degree of this polynomial is going to be 4, because we have the highest, or our highest degree is 4. I'm sorry, so the highest number of x-intercepts, or the maximum number of x-intercepts has to be 4. And that's going to be your final answer here. So we can just put 4. And very quickly to explain why, if you had something that's degree 1, let's get my pen back here, it's not selecting. So just to explain why, if we had something that's degree 1, it would look like this. There's a straight line, and it would pass through, or it can pass through, the x-intercept once. if you had that same idea here, so degree 2, it's going to be the same thing. So you have some x and y, and you can pass through at least twice. So that's something for degree 2. Degree 3, the maximum times that it could pass through the x-intercept would be 3 times. So there's once, twice, 3 times, and then this same pattern will just follow. So if they'd even asked you for something that's a really high degree, so like a degree 16 or a degree 7, rather than thinking too much about it, it will pass through however many, or the maximum times it can pass through is 7 times. So going back then to this question, when it asks you what's the highest degree, it's simply 4. I'm sorry, the highest number of zeros, it will give you 4. So there's your answer. Here we have, for question 3, one that involves polynomial division. So what is the remainder when this polynomial is divided by this one here? So setting this up, it's just like long division, but long division was probably done in grade like 4 or something, or grade 5. And so students need a refresher. So I'll write this out. We're dividing, whatever we're dividing by goes on the outside here. So this is going to be the x plus 2. And then the polynomial that we're dividing is x cubed minus 7x plus 9. Minus 7x plus 9. And it's very important that we write this in order of your highest degree to your lowest degree, which will be going from cubic to, we have a constant here. And we're going to intentionally leave a space here for 0 x squared. So I have going from x cubed to x squared to x, and then my constant. And this is a very important first step. And then when we're doing this polynomial division, you're asking yourself each time, what number do I have, or what term do I have to multiply to what I have here? So x to give me x cubed. So in this case, I need to have an x squared, because x squared, when I multiply it times x, will give me x cubed. And we're always looking for that same sort of pattern. So notice also that I put the x squared on top of the x squared like column that we have here. This is why I was mentioning like that you have to include this for yourself so that you're not going to forget what goes where. So x squared times x will give us x cubed, and then x squared times 2 will give us a positive 2x squared. And the next step here in the division is that we subtract the top column from the bottom one, so, or the top row from the bottom row rather. So I'm going to do that here. X cubed minus x cubed, that gives us 0. And then I have 0 minus 2x, which will give me negative 2x squared. And then the last step is to pull down the next term. So we're going to take the negative 7x and put that down. And like I said before, in this like pattern, now I'm looking for what is the number that when I multiply it by x will give me this term, this negative 2x squared. Because like in our first step, our goal is to find what it is that when I multiply it times x, I'll end up canceling it out like we did here. We had x cubed minus x cubed gives me 0, and I'm going to complete these steps. So for this one, I need to have minus 2x, because I know that minus 2x, when I multiply times x, that gives me exactly what I have here. So we'll do that like we did before. We're going to take the minus 2x, and we're going to multiply it. So that will first give me minus 2x squared, like what I want. And then my second term will be negative 2x times 2, which will give me negative 4x. And then just like before, we're going to subtract these two from one another. So from the top, I have negative 2x. I'm going to take away 2x. So you could even multiply both of these by the negative that's on the outside, which will give us negative 2x plus 2x. And this is going to be 0 here. And similarly, when we have multiplied that negative 1 to the second term, I'm going to have negative times negative, which will give me again a positive. So I'm left with negative 7x plus 4x. So I have to do negative, I'll have negative 3x as my answer. And then just like we did before, we take down the next term. So it's going to be plus 9. And now we're almost done. I see that I'm going to need to multiply, or I'll put on the top here, minus 3. Because a negative 3 or a minus 3, when I multiply it times x, is going to give me negative 3x. And so I'm going to do that here. I'll have negative 3x. I'm going to multiply the first term. And doing that for the second term, I'll have minus 6. And then again, we subtract these two from one another. So on the top one, we can first distribute this. So it may be easier for us to see. So these two negatives here will make this first term a positive. So I'll write that as plus 3x. And same here with the second term, that becomes plus 6. So now I'm doing negative 3x plus 3x, that's going to be 0. And I have a positive 9 plus 6 more will give me a positive 15. And so we ended up here with something at the end, which is our remainder. So what we write for our remainder is 15. So I can write it up here, that our remainder is 15, or whatever we get, divided by whatever we had here to start with. So it's going to be 15 divided by x plus 2. This is the remainder that we get, and this is the answer. Normally, or often, when you're asked to do this division, polynomial division, you'll just get 0. You don't get a remainder. But in this case, we do have a remainder. We had 15, and we take 15 and we divide it by whatever we're dividing our first polynomial by. So we're dividing it by x plus 2. So that's how I got that first answer. So it's going to be here. Our remainder is 15 divided by x plus 2. For question 4 here, this can be done quite quickly because there's a log rule dealing with these logarithms here. It says that if you have a base, in our case here our base is 7, that's raised to the exponent of log base 7, says that, how should I say it? Like these bases, or let me rephrase this. These two are basically opposites of one another. So this 7 here is like an exponential function. So it's 7 to the degree of a logarithm, and the logarithm is the opposite of an exponential. So you can think of these two as canceling each other out. And then the rule here is that whatever you have that's inside this logarithm, in this case it's the square root of 5, is what this simplifies to. So this is going to basically cancel each other out. This and this are opposites of one another, the logarithm and an exponential function. And then you'll just be left with the square root of 5. And that will be your final answer for question number 4. And what happens here is that, like, if you had anything, so just as another example, if I had 9 to the log base 9 of anything, so we can have like 3x squared plus 1, my answer here could simply just be written as, that's just the same as 3x squared plus 1. So this is coming from log rules, or logarithm rules, if you're unaware. So that's where that comes from. This one here, converting, we are given an angle in radians, and we want to convert it to degrees. And the easy way to do this is to first remember one thing, and that thing is that 180 degrees is equivalent to saying pi radians. And so if our intention is to get rid of the radians, or get rid of the pi here, we have to get rid of it by dividing by pi. So we're going to multiply this by our equivalent thing or fraction that we have here, and that's that 100, and let me also show this quickly in one more step. If I were to divide both sides of here by pi, I would get that 180 degrees divided by pi is equal to 1. And I think that everyone would agree that if you multiply anything times 1, it's going to give me the exact same thing. So here it's basically showing you that 180 degrees divided by pi is going to give you, or is equivalent to 1. So whatever I multiply this by, when I multiply it by 1, I'm going to get its equivalent form, but not in radians, but in degrees. And the reason why I'm going to get this answer in degrees is because I'm dividing both sides by pi, or the top and bottom, I'm sorry, by pi. So I don't have any more radians, and now I'm left with 180 degrees. So I'm going to have some answer times something in degrees, which is exactly what I want. If you were asked, though, the other way, so maybe you're given like 270 degrees, and you're asked, please convert this into radians. Rather than writing it like this, where I'm going to be using this fraction of 180 divided by pi, I can also rewrite this as pi divided by 180 degrees is also equal to 1. So with this same like logic, I'm going to multiply what I have up here times 1, or pi divided by 180. And we're going to see here that if I multiply this by pi divided by 180 degrees, these degrees are going to like be canceling out with one another. So I don't have any degrees anymore, and my answer would be in radians because I have the pi still left over. So in this like hypothetical example, I would get, I believe it's 1.5 times pi. So in other words, 270 degrees is equal to one and a half radians, or 1.5 pi radians. So that's just in that example. But in this specific example, the pi, as was mentioned, is going to cancel out with the pi on the top. And then you'll do 180 times 11 divided by 15. So if I do that in my calculator, I'll get this in degrees. Divided by 15, I get 132 degrees. So that's our answer there. For this next one, of question 6, it asks for the exact value of tangent 7 pi over 4. And so I'll make space for this one. So we'll imagine first for ourselves we have a unit circle here where this is 0 degrees, 90 degrees, or I'm sorry, we should use radians, so we should say that's 0, that's pi over 2, that's going to be pi, that's going to be 3 pi over 2, and then you get a full rotation of 2 pi. And we're asked for the exact value of the tangent of 7 pi over 4. So 7 pi over 4 is, if we look at what you have on the inside here, the 7 pi over 4 can be written as pi, or that's 4 pi over 4, plus 3 pi over 4. So we can imagine again, so this first part here, 4 pi over 4, that's just pi. So it's basically we're saying we're starting at 0, and you're going to rotate through this angle, so we get to pi. That's 4 pi over 4, and then we have to continue another 3/4 of pi. And pi is again half of this rotation, so I need to go 3/4 more. And so I'll end up somewhere here. So that will be 7 pi over 4 degrees. Or you could think of this as like almost 8 over pi. It's 8 pi over 4, I'm sorry. And 8 pi over 4 is the same as 2 pi. That just being a 2 there, 8 over 4. So we're, in other words, pi over 4 away from a full rotation. And this, what we're focused on here with this inner angle, this is called a reference angle. And this is just the angle that's made with the x-axis. So this is like our x here, our x-axis. And so when asked what's the exact value of tangent of 7 pi over 4, after we've found where that lies on like a unit circle, we then are going to find this reference angle. So our reference angle is pi over 4, and we're going to use this pi over 4 to find the exact value. And another thing that we need to also be considerate of is where we are on this unit circle. Because if you recall, there's a rule called cast rule, which goes like this, where C is here, A is here, S is here, and T is here. And all of these letters, the C, A, S, T, tell us where the trig ratio, so tangent, sine, or cosine, is positive. So where we are here in this quadrant, we're told that cosine is positive. Or in other words, that here, tangent, which isn't cosine, is going to be negative here. So I'm going to get a negative answer, and I'm going to also be using pi over 4, or tangent of pi over 4 as my answer. So this is equal to negative, because because tangent is negative here, tangent of pi over 4. And we're almost done now, because this pi over 4 is a special triangle. And always, 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 when you're asked about these questions about exact values, this is basically telling you that you need to know your special triangles. And the two special triangles that are taught are this one. So we have a triangle here where we're told here we have pi over 4. Here's pi over 4. There's your two angles. This is a right angle triangle. And the sides are 1, 1, and the square root of 2. This is one triangle. And the other special triangle looks like this. Here would be pi over 3, pi over 6, another right angle here, or 90 degrees. And the sides of this one are the square root of 3, 1, and 2. I'm going to double check as well if that may be given to you on your formula sheet. Because if it is, then you can always look back to it. But it is here, okay. So they give it here for you. So you could reference this, so you don't have to memorize it. I just also wrote these numbers here. They give 60, 30, 45 degrees. These are all written in degrees. The special triangle that I used, also they have logarithms for you. So you could reference that as well, like we saw earlier in the video. But you could reference that to finish this question, because now we're asked, okay, find tangent of pi over 4. Pi over 4 is going to be, or the angle is only in this triangle. So this is the triangle that we're going to use. And I need to find the ratio of pi over 4, or tangent of pi over 4, which is going to be, for tangent, if you remember SOHCAHTOA, tangent is opposite, so opposite of our angle is going to be 1, divided by the adjacent, or what's right beside us, 1. So it's going to be negative 1 over 1, or negative 1. That's our final answer here for question number 6. So the exact value here is -1. That's your answer. I'll just mark for ourselves the ones that we finished. So for question 7, this is a similar question. We're asked to find the equivalent trigonometric expressions for sine of 7 pi over 6 using an acute angle. So let's also first ask ourselves sort of like, what is this angle that we have here? What is 7 pi over 6? So we're going to use this image that we've drawn. I'm going to erase what we have. And look at 7 pi over 6 first. So 7 pi over 6. That's the same as saying 6 pi over 6, which is just the same thing as pi, plus pi over 6. So in other words, we're starting at 0. We rotate through an entire half rotation, or that's pi. So we started from 0, we went to pi. And then we're told to continue another pi over 6 more. So that's going to be a sixth of what we have here. So just roughly speaking, that's going to be somewhere down here. And so that's going to be a total rotation of 7 pi over 6. And so it asked us to find an equivalent expression for sine of 7 pi over 6 using the acute angle, or an acute angle. And this acute angle here is again going to be what's called the reference angle. And we saw that this first rotation from here to here, that's a whole, that's a pi radians like degree that we just went through, going from 0 to pi. And we saw that, well, this small angle, or the acute angle here, that we're making with the x-axis, is also called our reference angle, is pi over 6. So we're going to use pi over 6 to get our answer. And just like we saw before, we need to ask ourselves if sine is positive or negative here. So we're going to again use the cast rule to determine that. So it goes like this: C-A-S-T. And we notice that the only trig ratio that's going to be positive in this quadrant is going to be tangent. Or in other words, that when we have sine of 7 pi over 6, that's going to be something negative. So I'm going to start with a negative. And then using this reference angle, we're told we have, we're told the reference angle is pi over 6. And so we're going to find sine of sine of pi over 6 and multiply it by -1. And that's going to be our equivalent answer. And so again, we need to find the exact value. So we're going to use these special triangles. So for sine of pi over 6, sine is S, like if you remember SOHCAHTOA, so it's SOHCAHTOA. And so for sine, that's the ratio of the opposite angle, or the opposite side, divided by the hypotenuse. So for pi over 6, what's opposite of pi over 6 is going to be here. That's going to be 1. So our answer is going to be -1 divided by the hypotenuse. So we did O, and then we did H here. The hypotenuse is 2. So our equivalent expression here would be negative sine of pi over 6 using the acute angle, which is equal to -1/2. And I believe the question only asked for this part. It just asks for what's the equivalent expression using the using the acute angle. So this is what we would have as our answer: negative sine of pi over 6. So I'm going to write that as the final answer. So the equivalent expression, you could say that's equal to negative sine of pi over 6. And that's done.